guys. It's been a while since we've had a video. Get your little video thinking caps on. Today we are working out of page 163, section 4.2, ways to prove that quadrilaterals are parallelograms. There are a few theorems and a corollary that you have to write in your notebooks. I will be checking them tomorrow, so be prepared. I've got a little monkey hanging around my neck, and I've got a handy dandy holder of chalk. Pretty cool. Okay, the first one you're going to write is on page 163, theorem 4.4. I'm going to say it. I didn't write them all out today, but if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I drew an example here. So these both pairs of opposite sides are congruent. If you notice, that's 6 and that's 6, that's 5 and that's 5. There's no way I can draw something that isn't a parallelogram if the opposite sides are congruent. So I can call this a parallelogram because opposite sides are congruent. Over here, this side is 8, that side's 8, that side's 2, that side's 2. This is a rectangle, but a rectangle, as we know, a parallelogram has both sides opposite that are parallel. Because those opposite sides are congruent, I can call that a parallelogram. That's theorem 4.44. Theorem 4.5 says if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So I'm going to go back to here. Let's say we didn't know what that was and we didn't know what that was, but we knew that these were congruent and we knew that these were parallel. If that's the case, then that's going to be a parallelogram. Let's say I drew that's length 2 up there, and I drew on length 2 down here. If I knew that those were parallel and that they were the same length, all I have to do is connect the two edges, and I've got myself a parallelogram. Okay, so that's theorem 4.5. Theorem 4.6 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So both pairs of, opposite angles. I didn't say that right. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Over here, I have both pairs of opposite angles congruent. These two are 100. These two are 80. When you have that case, I can call this a parallelogram. So we're trying to call quadrilaterals parallelograms. So we're kind of going backwards from what we've already learned, so that I can call that a parallelogram because both sides of opposite angles are congruent in the quadrilateral. Theorem 4.7 says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So let's just take this quadrilateral. If these things, even though I already showed you here that they're parallel, but let's say these two things bisect each other and I find out that this is congruent to this and that is congruent to that. If that's the case, then that becomes a parallelogram. Okay, so that's theorem 4.7. I also want you to list 5 ways to prove that a quadrilateral is a parallelogram. The first one is show that both pairs of opposite sides are parallel. Show that both pairs of opposite sides are congruent. Show that one pair of opposite sides are both congruent and parallel. Show that both pairs of opposite angles are congruent. And show that the diagonals bisect each other. Basically just going over those theorems that we just went over to show that you have a parallelogram. 2 more. Ready? Theorem 4.8. Well, let me just show you. I did draw some things that aren't parallelograms. This is a trapezoid. Let's say these aren't really good parallel lines, but let's say they were parallel, and that was 2 and that was 4. When I connect the edges that are, see, opposite sides are congruent. However, these two opposite sides aren't congruent, and therefore this is not a parallelogram, it's a trapezoid. It's still a quadrilateral because a quadrilateral has 4 sides. How about over here? This side kind of slants up at 6 to make that 2 and that 3 and that's 5. That is not a parallelogram. Okay? Theorem 4.8, we're going over here. If 3 parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So, okay, here's a transversal. If this is a transversal, and these are parallel, so we have to know if these are parallel, okay? Let's say those are parallel, and here's my transversal, and I say that this is congruent to this. What this theorem is saying is that if this transversal has congruent segments, then these two are going to be congruent to each other as well. If I drew another transversal, that's going to be congruent to that. If I drew another transversal, that's going to be congruent to that, okay? Because these are parallel lines, no matter which way you slice your transversal, you're always going to have congruent segments. The last one is a corollary, and it says a line that contains the midpoint of one side of a triangle and is parallel to another side bisects the third side. Okay, so here is a line, and it contains the midpoint of one side of the triangle, which is this. So if this line is parallel to this line, okay, and when I drew this, I kind of didn't draw very good parallel lines, but let's say this line is parallel to this line, and this line, this is a midpoint, then in the triangle, that's going to be a midpoint of that segment, because it bisects the third line. So that means that becomes the midpoint of this segment, this is the midpoint of these two segments, if these two are parallel. And then look, you got two parallel lines, this is a transversal, those, wait a minute, these become alternate interior angles. I just got sidetracked a little, kind of going off track here, because we're talking about midpoints, so just disregard that, but these two are equal to each other. Okay, I hope you have a good day, and the key word is monkey around my neck.